Recently, during the monsoon, a new LED failed. Everyone blamed the brand, but the real reason was a lightning strike. Hey everyone, my name is Sahil, and in today's video, we will understand 10 signs that your structure was struck by lightning. But why should you listen to me? At Axis, we've been manufacturing a wide range of earthing and lightning protection devices for the past 30 years. This includes lightning arresters, earth pits, earth rods, and everything else that you see. You will see our products installed in solar farms, data centers, commercial and residential projects in more than 100 countries. But why is this topic so important to discuss? We all know how lightning strikes. It hits the tallest object and sends a high current into the ground. But even when it does not strike a structure directly, we still end up losing our favorite electronics. This is called an indirect strike. The current finds another way in through connected power lines, metal fences, pipes, or even the ground. That surge enters the system and damages your electronics. Most people only look for burns or roof damage, but the real threat may already be inside. Therefore, we will look at these 10 signs in detail, starting with direct strikes. So the first sign you should look for is spark at the bottom of the strike. Look for burn marks or black spots on roof edges, metal pipes, antenna mounts, solar panel frames, or any metal part at the top of your structure. This sign shows the exact point where the lightning entered the building. When lightning hits metal, the current jumps through the air and creates a spark. That spark burns the surface. And if you see this, expect damage along the path of that current. The down conductor, surge protection devices, and nearby electronics may also be affected. Number 2. Melting of metal parts. You will see melted or deformed metal on rooftop structures like solar panel frames, lighting arresters, antennae, or cable trays. The metal may look bent, sagged, or partially melted. This sign shows that a strong current passed through that metal, heating it instantly. Lightning can reach temperatures high enough to melt metal in a split second. If you see this, expect that the connected conductor may also be weakened. Thirdly, mechanical or electrodynamic effects. In this case, you will likely see that metal parts like bus bars, cable trays, or clamps have shifted, bent, or become loose after a strike. This can happen inside panels, junction boxes, or internal electrical wiring. This sign means that a large amount of current has passed through the conductor, creating a strong magnetic force. This force can physically push or pull the metal, even though the strike lasted for only a few milliseconds. Now you might be thinking, how is this different from the above signs? First, we saw a spark at the entry point. In the second, the metal melted from the high temperature. But here, nothing burns or melts. Instead, the magnetic field around the current pushes the metal, causing it to shift or bend. If you notice this, expect nearby joints or terminations to be loose. Check all electrical enclosures for signs of movement, arcing, or overheating. Next, let's discuss indirect strikes. This occurs when lightning hits nearby and the current enters your structure through the ground, cables, or magnetic fields without direct contact. Now let's look at the signs of an indirect strike. Firstly, sudden damage to electronics. You might notice TVs, routers, inverters, or control panels stop working right after a strike. The device looks normal from the outside but will not turn on or keeps restarting. This happens when a surge travels into your building from outside, usually through power or communication cables. Even if lightning hits far away, the surge can travel any connected line and reach your equipment. Secondly, voltage rise due to inductance. In this case, the damage does not come from outside, it is generated inside your wiring. When lightning is nearby, the sudden change in current creates high voltage in long wires. This is called inductance. You may not see any damage outside, but devices can still fail or SPDs can be damaged, especially in buildings with long cable runs or coiled wires. If you're finding this video helpful, please subscribe to our channel for more insightful videos on electrical engineering. Thirdly, heating of conductors. You will notice discolored insulation, a burnt smell near cables, or melted cable jackets. This usually happens near panels, bus bars, or long cable runs. This sign shows that a large surge current passed through the conductor, causing it to heat up very fast. Even if the cable looks fine from the outside, the insulation inside may be damaged. If you see this, Expect nearby terminations, joints, or breakers to be stressed. Test installation resistance and check all important connections. Fourthly, electromagnetic induction. Sometimes after lightning strikes, equipment like routers, controllers, or monitoring devices start acting strangely. They restart, freeze, or show data errors. This often happens with devices connected by long signal cables. This sign means lightning passed close to the structure and created a strong magnetic field. That field induced voltage in nearby cables even without any contact. This effect is called electromagnetic induction. You might think this sounds like the earlier signs, but here the surge is not coming through power or communication lines, nor is the voltage building up inside your own long cables. It is instead created directly by the magnetic field from the nearby lightning strike. Fifthly, touch potential. There may be no visible damage, but during or just after a strike, if someone touches a down conductor or any metal part such as a railing, gate, pipe, they might feel a shock or a burn. This happens because the metal part is at a different voltage than the ground or nearby surfaces. When lightning strikes close by, the current spreads through the ground and the metal, and for a few seconds, the two connected surfaces may not be at the same voltage. If someone touches both at the same time, the current can pass through their body. This sign tells us that some parts of the structure are not bonded properly. It becomes a serious safety risk during a strike. Now, sixth, step potential. During a strike, a person or animal who's walking near the strike area might collapse, feel a shock, or show signs of muscle injury. This happens when lightning hits the ground and the voltage is spread out in all directions. The voltage is highest near the strike point and reduces with distance. If your feet are apart, each foot touches a different voltage gradient. That difference causes current to flow through your body. This sign shows that the area around your structure is not safe during a strike, especially for outdoor workers or animals. We have explained the step and touch potential in detail in our previous video. The link is in the description. Now, seventh, ground potential rise. After a strike, you may notice equipment shutting down, surge protectors getting damaged, or communication systems failing without any visible fault. This happens when lightning strikes the ground near your structure. The current spreads through the soil and raises the voltage of your entire earthing system for a few seconds. That high voltage can enter through earthing points, cable shields, or metal pipes. This sign shows that the strike energy entered from below, not through overhead cables. It affects everything connected to the earthing system. If you see these effects, test the earth resistance and check all earthing bonds. Also check for signs of breakdown in surge protection devices. I hope you now have a clear understanding of the 10 signs of a lightning strike. The lightning protection systems manufactured at Axis are designed to handle both direct and indirect strike conditions as seen in real-world installations. At Axis, we have a team of 50+ engineers who are here to help you in designing, installing, and testing your lightning protection systems. Our products have been used in substations, data centers, factories, and even in everyday residential and commercial buildings. Thank you.